So representing aqueous reactions. We've looked at precipitation reactions. And we're going to look at some different ways of representing reactions. So we have, of course, the molecular equation. And this is what we think of as a regular chemical equation. This is going to show complete neutral molecules or complete neutral formulas for each compound as if they existed as molecules. So here we've got an example of potassium hydroxide reacting with magnesium nitrate to form potassium nitrate and magnesium hydroxide. The magnesium hydroxide is insoluble, and so that forms a precipitate that falls to the bottom of the beaker. But this seems to suggest that potassium hydroxide dissolved in water is actually little molecules of KOH, when that's not the case. This is an ionic compound, and so it separates into individual ions. And that's the same with all of these aqueous ionic compounds. So those soluble ionic compounds are actually present as ions. So we can also write what's called a complete or a total ionic equation. And that shows all of the species as they actually are in solution. So if it's individual ions, we write them as individual ions. That gets a bit tedious. So we'll often use what's called a net ionic equation. So the word net here means it's like your net pay, right? There's the gross pay, and then they take out all the taxes, and then you've got your net pay. So the net ionic equation is sort of the bottom line. It's only the things that are actually reacting. So how do we write a complete ionic equation? Well, any aqueous ionic compounds we're going to write as ions. So pretty much anything that has AQ in it and is ionic, you're going to write as individual ions. The one exception that we should watch out for are the weak acids. So weak acids are not one of the 6 strong acids. I'm not going to try to trick you with this one in this class. If you have solids, liquids, or gases, you just leave them alone. Anything that includes all the insoluble things. So here's our example, lead nitrate and potassium chloride reacting to form lead chloride and potassium nitrate. So this first one, lead nitrate, that's a soluble ionic compound. And so we write the ions individually. So we've got lead 2. We know the charge on lead because of the charge on the nitrate ions. And we have 2 nitrate ions. So when we separate this thing, we end up with 2 nitrate ions. Here we have KCl. There's 2 molecules of that, or 2 formula units of that. And so we end up with 2 potassium ions and 2 chloride ions. In the products, lead chloride is a solid. So we see that S is the state symbol. We leave it alone. Just copy it down. And then 2 potassium nitrate. This, again, is a soluble substance. And it separates into the ions, and so the ions are floating around in solution. So writing 2K plus 2NO3 represents more accurately what's going on in that reaction container. Any questions? Yeah.
One more time where the PB chloride dinner.
Yeah, so lead 2 chloride is insoluble. So we can look at the solubility rules, or we can just look at the S here. That means it's a solid. It does not dissolve. It does not separate into ions. And so we write it as an intact thing because that represents what it does in solution. Sometimes students get confused about, well, what do I do with these subscripts, right? Remember that subscript is telling us how many of those ions we have. So the formula for that ion is not NO3 in parentheses 2. The 2 is telling me I have 2 of those ions. And so it's 2 of the NO3 minus. Any other questions? So the complete ionic equation, we've got all the ions in there. Some of those ions, though, don't actually participate in the reaction. We can identify them because they appear as a reactant and as a product exactly the same. Nothing happened to them. You go to watch a boxing match, right? The people in the ring get all beat up, right? They come out with bloody noses and black eyes and stuff. You're sitting in the stands. Does anything happen to you? No. You're a spectator, right? You're just watching the action. Nitrate ion is a spectator in this chemical reaction. It's not participating, it's just hanging out. It's one of those people at the party that's watching these people get it on, right? They're like, ooh, they really like each other. But nitrate didn't get involved with anybody. So this is a spectator ion. Potassium ion is also a spectator ion. There's 2 potassium ions over here, and in the products there's still 2 potassium ions by themselves. They're spectators. So the net ionic equation, we just don't write the spectators. So we leave the spectators out, we write down everything else, and so the net ionic equation, pointer's gone. Whatever, pointer's not working. At the bottom there, we have lead 2 plus, aqueous, plus 2 chloride ions, aqueous, forming PbCl2 solid. So that's actually what's going on. The nitrate and the potassium are there, but does it really matter that chloride came with potassium instead of sodium or some other person? No, it doesn't. Any questions? Let's do some practice. Consider the following reaction, blah, blah, blah. Write the complete ionic and net ionic equations for this reaction. So we're given the balanced molecular equation. We're going to look at each of these species, and if it's aqueous, we are almost certainly going to separate them into ions. Now, of course, the first one gives us a little bit to think about. What kind of a substance is HI? Ionic, molecular, or acid? It's an acid. Is it a strong acid or a weak acid? It's a strong acid. HCl, HBr, and HI are the strong acids. So a strong acid you separate because strong acids ionize completely. A weak acid you do not separate into ions because most of it is present as intact molecules. So we are going to separate this into ions. So we need to know what the 2 ions are. Well, we're going to get H plus. That's going to be aqueous. And the other ion is going to be I minus. And that's aqueous. So if you struggled with the nomenclature and the making ionic formulas, you're going to have trouble here. If you need help, please ask. There are 2 of those. So we can balance it as we go along, or we can balance it later. I prefer to balance it as I go along. There's 2 of those units, so I'm going to end up with 2 hydrogen ions and 2 iodide ions from those 2 units. The next one, barium hydroxide, aqueous. This is a metal, so this is an ionic compound. We're going to separate it into ions. So I need a barium ion. Got to put the charges on there. And how many hydroxide ions are there going to be? 2. So we've got 2 OH minus, and that's aqueous. There's my arrow. My first product is water. The state symbol is L for liquid. Leave it alone. Just copy it down. 2H2O liquid, 2H2O liquid. And then the last one, aqueous, an ionic compound, separate that into its ions. So I'm going to get barium ion. And what's the other one? 2 I minus. This 2 is not part of the formula for the ion. That means there are 2 of those ions, okay? So there's my complete ionic equation. Any questions? Yeah.
You say we leave the compounds alone if they're just solid, or does it matter?
Solid, liquid, or gas. You leave them alone.
Okay.
Because that is their state. So water existing in this situation is a liquid. It doesn't separate into ions. So it's only the aqueous things that we're going to represent differently, and it's all but the weak acids. Any other questions? Yeah.
How come we're not splitting up the O and the H in the hydroxide?
Good question. Why not split this up? So this is an ionic compound, and in Chem 1A, all ionic compounds have two ions. One cation, one anion. So OH minus is a polyatomic anion. When barium hydroxide dissolves in water, we get barium ions and hydroxide ions. The hydroxide ion does not split up into hydrogen ions and oxygen ions. And that's something you just got to believe me about. Any other questions? So there's our complete ionic equation. The net ionic equation, we're going to look for the spectators. So the spectators are the things that appear the same in the reactants and the products. Do you see one of them? Barium. So here's barium aqueous, same charge, same number of them, everything's the same. He's just floating around. That's what he started doing, and that's what he ends up doing. What's the other one? Iodide. There's two iodide ions in the products and two iodide ions in the reactants. So then we're going to just copy down everything that's left. So I've got two hydrogen ions and two hydroxide ions. And in my products, I've got two water molecules. So that's pretty good. We could make it a smidge better. What's odd about that chemical reaction? It could be simplified. Everything has a coefficient of 2. It would also be balanced if it didn't have any coefficients, right? And I won't try to trick you with this on an exam either. But chemical reactions should be written with the lowest ratio of whole number coefficients. So we could just cross off those 2's. And that's our best net ionic equation. Questions?